All right. Thank you all for joining us today for the Hatfield Marine Science Center Summer Seminar. My name is Mariana Hinojosa. I am the Special Programs and Course Support Coordinator here at Hatfield Marine Science Center in Newport, Oregon. I will be your host for today's talk. And for those online, we have Jamie as our hybrid support. So if you can't see me or hear me, please let us know in the chat. Also drop any questions or technical challenges in there, and we will take care of that for you on this end. And we also have your mics, cameras, and screen shares off. We will be asking questions at the end of the talk today, so please drop any of those into the chat, and Jamie will ask them on your behalf. For those of you in the room, if you've not already, please make sure you sign in on your way out. That is how I can validate buying cookies and coffee for everybody. And we, again, will be handling questions at the end of the chat. Renee and I will be walking through the room. Just raise your hand, and we will give you the microphone so you can ask your questions so everybody online can hear you. We will be recording this event, and it will be posted in the next few days on the HMSC past seminar page. A couple of announcements before we get started. Next week, we have the Marine and Estuarine Invertebrate Zoology class presenting their group projects on aggression and colony behaviors of aggregating anemone, Anthoplura elegantissima. The presentations on the Anemone Fight Club, as many folks on campus lovingly know it as, will be held next Wednesday, August 13th, here in the auditorium, starting bright and early at 8 a.m. So we hope to see you there. Save the date for the Coastal Intern Symposium happening 2 weeks from now on Thursday, August 21st. There will be no seminar that day, but instead we will have a poster session here in the Marine Studies building where summer interns will be sharing about their summer projects on a variety of ocean-related research topics. Stop by between 10 a.m. and 2 p.m. to check out their posters on the 21st. Lastly, for next week's seminar on Thursday, August 14th, we will be joined by Dr. Lou Whitebear. As an Indigenous Studies faculty at Oregon State University with a background immersed in Indigenous science, Dr. Whitebear will share her experiences and research that center impacts of scientific research on Indigenous communities, especially as related to extraction, as well as her experiences working on projects related to natural resource protections. She will highlight topics such as natural resource extraction, climate change, and the role of Indigenous science and cosmologies in navigating scientific research. Now for the reason we are all here. Today's speaker was invited to Hatfield by the Marine Mammal Institute, so I will pass the mic to Dr. Renee Albertson to introduce our speaker.
Thank you, Mariana. I'm very pleased to introduce my friend and colleague, Dr. Robin Baird. He is a research biologist and the Hawaii Program Director for Cascadia Research Collective, a nonprofit research and education organization. He's been studying cetaceans since 1985 and received his PhD from Simon Fraser University in 1994 with his thesis focused on foraging behavior of mammal-eating killer whales. While based in Olympia, Washington for the last 27 years, his research has primarily focused on Hawaiian dolphins and whales. He is also a member of the Pacific Scientific Review Group, an advisory body for NOAA fisheries, the research alternate member of the Sanctuary Advisory Council for the Hawaiian Islands Humpback Whale National Marine Sanctuary, and a conservation primary member of the Sanctuary Advisory Council for the Papahānaumokuākea National Marine Sanctuary. So with that, I will turn it over to Robin.
Thank you, Renee. Thank you, everyone, for coming. Before I get started, I just want to mention that the science that I'm going to be talking about is a long-term project. It's been funded over the years, primarily by grants from NOAA Fisheries, with some support by the U.S. Navy and contracts through the state of Hawaii from funding that's come from NOAA Fisheries. We have a number of people that have played a critical role in the field that are listed here. And we've also had some collaborations with folks at Pacific Island Fisheries Science Center, Southwest Fisheries Science Center, Northwest Fisheries Science Center, and Pacific Whale Foundation, among others. So now the U.S. arguably has, perhaps just until recently, the strongest legislation worldwide for protecting marine mammals, both through the Marine Mammal Protection Act and through the Endangered Species Act. Both of those acts are really based on science, and in the case of whales and dolphins, the science, a lot of it is driven by the various science centers. In Hawaii, Pacific Island Fisheries Science Center and Southwest Fisheries Science Center played key roles. But the management happens independently within the same organization, but it's driven by the regional offices and by Office of Protected Resources. And I'm going to talk today about some of the differences between support for the science and support for management actions in Hawaii in relation to one particular species, and that's false killer whales. Now, research on false killer whales first began in Hawaii in the 1980s. Dan McSweeney, who was an independent researcher, started systematically getting photos of false killer whales and several other species, including 2 species of beaked whales and short-fin pilot whales and pygmy killer whales. And at the time, he was the only researcher in Hawaii that was really paying much attention to anything other than spinner dolphins or humpback whales. In 1989, Steve Leatherwood and Randy Reeves did some aerial surveys specifically focused on false killer whales in Hawaii to count groups, and I'll talk a little bit about some of their results later on. I started work there in 1999, set up a photo ID catalog off of Maui of false killer whales, and in 2000 began biopsy sampling and collaborating with Southwest Fisheries Science Center on the genetic analyses of those. And the first abundance estimate for false killer whales I should say another monitoring effort that provided a lot of information on false killer whales came from the observer program in the offshore longline fishery. And in 2000, that observer coverage increased to 20% from just a couple percent. So that made a big difference in understanding interactions between false killer whales and fisheries. The first abundance estimate also became available in 2000. These were aerial surveys that Joe Mobley had been undertaking primarily to estimate abundance of humpbacks, but had been recording other species of whales and dolphins that he would see, and produced a report coming up with abundance estimates of a number of those other species. And that first abundance estimate was just 121 individuals around the main Hawaiian Islands. And when you have some bycatch estimates and abundance estimates, what National Marine Fisheries Service does with those is calculate the potential biological removal level and then look at bycatch in relation to that. And so in 2000, they were able to do that for the first time with false killer whales and concluded that bycatch was exceeding the potential biological removal level, which makes that population strategic in the eyes of National Marine Fisheries Service. And that strategic designation meant that what it could have done, or perhaps should have done, is trigger the formation of a take reduction team to come up with ways of reducing bycatch. Now, of course, there was a lot of uncertainty. The estimate of abundance was only from around the main Hawaiian Islands. It was only one estimate. And because of uncertainty and I think other reasons, just a lack of attention, nothing was done fairly quickly. In 2003, the first EEZ-wide abundance estimate became available, and this is from surveys undertaken by Southwest Fisheries Science Center, led by Jay Barlow. And for the entire exclusive economic zone, the abundance estimate was just 268 individuals. So again, in the light of the small area that the aerial surveys were undertaken in, that 268 suggests that the abundance within Hawaiian waters overall was quite small. The population would have still been strategic from that new estimate. And then in 2005, we came up with a mark recapture abundance estimate around the main Hawaiian Islands of just 123 individuals. So all through that first part of the 2000s, what was available from abundance and what was available from bycatch suggested the population was strategic and a take reduction team was needed. Now, I'll digress a little bit to tell you about the interactions, or why the interactions between fisheries and false killer whales occur. Are any fish people here in the audience? Anyone want to identify this fish in between these two false killer whales? It took us a long time as well. When we first got this photo from last July off of Lanai, we were looking at photo trying to figure out what that very strange gray thing is in between these two false killer whales. Fortunately, with these wedge-tail shearwaters as a size indicator, I showed this to a fisherman friend, and he said it was probably about a 10-foot long broad-billed swordfish. So false killer whales eat large billfish. They eat almost everything they eat, in fact, are species that are targets of human fisheries. So the species we see them feed on most often are mahi-mahi, the one up in the upper right corner, but we also see them feeding on ono or wahoo in the upper left corner, the mongchong in the middle right, opa the bottom right. This is another broad-billed swordfish here on the left, and we see them feeding on yellowfin tuna, big-eyed tuna, albacore tuna, skipjack tuna. So all of these species are species that humans like to catch, and it's that nexus that really creates the problem. Now, in 2005, we published the first evidence that false killer whales around the main Hawaiian Islands were potentially getting injured or killed from fisheries interactions. The photo in the middle is actually from an observer in the longline fishery. Eric Forney, who's the brother of Karen Forney, for some of the in the audience knows. He was an observer at that point, and it's a false killer whale struggling against a taut line. And there's actually an abrasion along the side of the body. And this type of struggling against gear when hooked in the mouth and combined when you see some of the videos of hooked false killer whales really provides a mechanism for the types of injuries that you can see in the photos on the right-hand side. One individual in our early catalog was missing the dorsal fin entirely, and from scar tissue along that surface, it wasn't just a congenital thing, it had been cut off in some way. And a couple other individuals had these very large leading edge cuts in the fin that had caused their fin to collapse. I'll actually say these photos are all of animals that had acquired these injuries at some point in the past. We have an individual that we had a fresh dorsal fin injury in 2016, and we've been tracking that individual over the last 9 years, and its fin just in the last year has completely collapsed, and it's showing some evidence that from that leading edge injury and the collapse, it may be the whole fin may end up coming off at some point because it's starting to break down more. But anyways, at the time of this paper, the only observer program in fisheries in Hawaii was the longline fishery. We assumed, and it's in the title, that these false killer whales around the main Hawaiian Islands were going offshore and interacting with the longline fishery. Now, in 2007, led by Susan Shivers at Southwest Fisheries Science Center, a paper was published that provided evidence that there are multiple populations of false killer whales, both in Hawaiian waters and more broadly. This graphic on the right shows the mitochondrial haplotypes. The ones in blue were sampled around the main Hawaiian Islands, very closely related dominant haplotypes. And those were different from false killer whales that were sampled elsewhere in the central tropical Pacific or eastern tropical Pacific and elsewhere. And a combination of the genetic data and our building catalog from photo ID data both suggested that there was a separate demographically independent population of false killer whales around the main Hawaiian Islands, and that was different from the false killer whales that were in offshore waters and probably the ones that were interacting most with the offshore longline fishery. And I will point out, so this is a social network on the right-hand side, false killer whales that have been photo identified through 2006. Almost all of them are linked in that main component of the social network, except for this one big large group, and that cluster was seen quite far offshore. And we now know that that cluster is what we would call part of the pelagic population. We've had resightings of them much further offshore, and there are no linkages, no social linkages between the island-associated false killer whales and these offshore false killer whales. Now, that information led in the stock assessment report for 2008 for NIMS to recognize two different populations in Hawaiian waters, the Hawaiian insular population and the Hawaiian pelagic stock. And because the bycatch in the longline fishery is largely offshore, combined with the EEZ-wide abundance estimate from Barlow, it led to this Hawaii pelagic stock being considered strategic. Again, something that should trigger a take reduction team. Now, there are no observer programs in any of the nearshore fisheries, as I mentioned. So really, there's, based on, some people would say, well, there's no bycatch, rather than that just there's no evidence of bycatch. So the insular stock was not considered strategic. Now, in the next year, 2009, other types of management issues were becoming apparent for this main Hawaiian island, now recognized as a main Hawaiian island insular population. And I'm going to talk about two of these. One was going back to that aerial survey that Randy Reeves and Steve Leatherwood had undertaken in 1989. They actually had funding from Sea Life Park, which was trying to get a permit to do live captures of false killer whales in captivity, and they had to come up with a minimum abundance estimate to support the permit application. So they were specifically looking for false killer whales. They were photographing groups they encountered, and the findings from that survey were not published until 2009, so they had been largely ignored. But I worked with Randy to get them published when it became apparent that there were a number of management issues with the main Hawaiian Island population that weren't really being considered. They were the third most frequently encountered species in their survey compared to the same surveys that we were doing around the main Hawaiian Islands at that time. They were the 7th or 8th most frequently encountered. The 3 different days, they had groups of over 300 individuals. And we now know, based on our satellite tagging work, that those very large groups were occurring or were being spotted in areas that we would consider very high density areas for false killer whales today. And the counts from those groups, the largest counts were 460 and 470 individuals, which are dramatically larger than the existing abundance estimations. So that provided the first evidence that the population may have declined dramatically between the late 1980s and the 2000s. Turns out Joe Mobley's aerial survey work that I mentioned earlier had continued for a couple more years, and he had never published any year-specific sighting rate estimates. So Joe provided the data, and I included it in a report to the Marine Mammal Commission in 2009. And even though he had sighting rates per unit effort for 5 different species, only false killer whales were showing a decline, and the other species were showing no particular patterns increasing and decreasing among the species. Again, another line of evidence that the population was declining. So this evidence of a separate island-associated population that was declining, and it had evidence of fisheries interactions and other threats, was used by the Natural Resources Defense Council, who submitted a petition to NMFS to list the Hawaii insular population under the Endangered Species Act. That happened in September 2009. NMFS acted very quickly. There was a 60-day finding that basically said there's enough evidence in this petition to go forward with a biological review team. They convened that team, and they acted in a very timely manner. Within 6 months, produced a status review. And the status review concluded several things. It was a distinct population that was significant under the terms of the Endangered Species Act, and that there was evidence that the population was probably endangered. So NMFS, just a couple months later, again, going from the science side of NMFS to the management side of NMFS, a couple months later, proposed an endangered listing under the Endangered Species Act. Nothing happens quickly on the management side. A year and a half later, NRDC submitted a 60-day notice of an intent to sue them for the lack of action. You know, once they propose an endangered listing, there's a public comment period, and then a set period of time where they're supposed to follow through with that listing, and they didn't do that. So as part of that, there was a settlement, and in November 2012, NMFS listed this population as endangered under the Endangered Species Act, basically effective at the end of 2012. So one of the things that they're supposed to do when there's an endangered listing is designate critical habitat. They're either supposed to do that at the time of the listing itself, or if there's insufficient information, they've got 1 year to do that. Conveniently, we published a paper a few months prior to the final listing decision that was going to make it as easy as possible for them to do that. We used our satellite tag data, which I think was up to 27 individuals at that stage. And I've got one of the limpet tags for those of you who haven't seen a limpet tag. You can take a look at it if you're interested. And we basically showed the range of the population, the two maps on the right, as well as the preferred habitat depths that they're using, the graphs in the middle, to basically try to set it up. They had all the scientific information that was available at the time in a peer-reviewed paper that they could use if they had wanted to. So again, this was December 2012 when this all went through. It took a lawsuit in July of 2016 because they just hadn't taken action on the critical habitat to force some action. They published a proposed rule in 2017, and then the final rule in July of 2018. So the false killer whale critical habitat that came out in this final rule was generally what you would expect based on the science. They basically set it as all areas between 45 meters depth and 3,200 meters depth around the main Hawaiian Islands, with a few carve-outs. And those carve-outs, some of them are for military activities, the Alinuihaha Channel between Hawaii and Maui, the channel between Kauai and Niihau, which is those two areas are two areas that are quite important for the Navy. There's also a couple call-outs for wind energy development. But other than those, I think they did a good job at basically setting aside the area's critical habitat that the science suggested they would have. Now, going back to the science side of things, there's just sustained investment by National Marine Fisheries Service in false killer whale science. And I'm going to talk first about insular false killer whale science and then a little bit about pelagic false killer whale science. And a lot of that science was done by the science centers themselves, as well as by Cascadia Research and also by Pacific Whale Foundation. Now, this early paper in 2013 actually provided evidence that there's a third population in Hawaiian waters, what's now recognized as the northwestern Hawaiian Islands population of false killer whales. And that was based on some satellite tagging animals that the Science Center did that basically remained entirely around the northwestern Hawaiian Islands, genetic analyses that showed they were closely genetically related to the main Hawaiian Island population, which suggests they all came from a single colonization event, and the photo ID that showed that while there were re-sightings of these individuals to other animals that have been photographed off of Kauai, there were no connections to the social network from the main Hawaiian Islands. And since then, the northwestern Hawaiian Island population hasn't received much attention, but the main Hawaiian Island population has. Long-term research programs that have looked at genetic differentiation and relatedness between populations and relatedness within the population, abundance estimation, persistent organic pollutants, social organization. And I'm going to talk about a couple of these particular papers as they relate to the threats that the population was facing. So I'd mentioned that 2005 paper that showed a couple percentage of individuals had those major dorsal fin disfigurements that were indicative of fisheries interactions. This 2015 paper basically showed, with much larger sample sizes, as well as photos from both the northwestern Hawaiian Island population and the pelagic population, that individuals from the main Hawaiian Island population have a much higher rate of evidence of fisheries interactions. In this paper, about 9% of the individuals in the catalog had these types of injuries. This, by the way, is the individual I mentioned earlier that had the fresh wound in 2016 and one that we've been able to track over time. Now, we also published a paper last year, again with much larger sample sizes, but importantly, this paper also incorporates mouthline photographs. And the mechanism for these injuries is that the animal gets hooked in the mouth and then struggles against the gear. And so what you would expect is just some smaller proportion of those individuals would end up with the dorsal fin injuries. And lo and behold, that's what we found. This compares the three different populations with dorsal fins and with mouth lines. Sample sizes for mouth lines get very small, particularly for northwestern and Hawaiian Island populations. But if you look at the very last column, almost 29% of the individuals in the main Hawaiian Island population have one or both types of injuries that suggest they've survived a previous fishery interaction, compared to none of the northwestern Hawaiian Island individuals. And in this case, for those that have both types of photos, none of the pelagic individuals. And there's a couple possible explanations for this. The pelagic animals we know are interacting with longline fisheries. The observer program sees them. Animals are killed. But it's possible with the very heavy longline gear that a much higher proportion of the animals that do get hooked just die as a result and are not left with these types of injuries, compared to the much lighter weight gear that's included in a lot of the fisheries around the main Hawaiian Islands. Alternatively, it's also possible that the insular animals are just interacting with fisheries much more frequently. And we have some evidence, some groups, for example, pelagic individuals that have no individuals with injuries and others that do. Whereas if you look at the main Hawaiian Island population, so these are 4 different clusters that are recognized within this population. If these were killer whales, we'd call it pods rather than clusters. But the distribution of individuals that have evidence of having survived fisheries interactions are widespread throughout the social network, although there is some evidence that there's different cluster-specific rates that are occurring. So for example, cluster 3, 38% of the individuals in that cluster have this type of evidence, whereas cluster 2, just 19%. And I will mention that I'm going to show in a couple minutes some information on the trends for this population for a paper that we have coming out next week. But the cluster 2 is the only cluster of the 4 that's not showing any evidence of a decline in abundance over the last 10 or so years. Now, we know that our estimates of injuries are negatively biased, and there's 2 reasons for this. One is there's a relationship between the probability of detecting an injury and the quality of the photo, as well as the length of the time interval between good quality photos. And so for groups that are seen less often or individuals that are seen less often, they are often acquiring these injuries, and the injuries are healing completely to an extent that we can no longer detect them. But mouthline injuries are also negatively biased because we don't have good photographs of both sides of the mouth line. And those that do have injuries have a higher proportion of the mouth line visible than those that don't, which is pretty clear that part of what's going on is just that we're incompletely sampling individuals for their rates of injury. Now, I mentioned a paper that we have coming out next week. I think it's scheduled to be published on Thursday. And this is the first time since this population was listed as endangered that there's any trend information available. We've had abundance estimates, but the uncertainty associated with those abundance estimates haven't really allowed for assessing a trend. And this paper takes satellite tag data and survey effort and uses those to come up with a detection probability. And it's a more robust method for estimating abundance. Since the population was listed as endangered in 2012, it's been declining at an average of about 3.5% per year. And I mentioned that those rates of decline vary among the clusters, with the lowest rate, well, with no evidence of a decline for cluster 2, and particularly high rates for, I believe, cluster 4 and cluster 1, although Michaela could probably correct me if I'm wrong on that. So what are the management steps that have been taken since this time, since the population was listed as endangered? We've known, the first paper was published in 2015 on those fisheries interactions, but we presented it to the Pacific Scientific Review Group at least 2013, shortly after the listing, and really there have been none. This is not a mistake. That's deliberate. There have been no management steps to mitigate threats from nearshore fisheries to this population. And I'll talk a little bit more in a minute about why I think that is. So now I'm going to switch a little bit to the pelagic population and the false killer whale take reduction team. And again, I had mentioned earlier that this population or back before it was even recognized, this population was considered strategic. It wasn't until NMFS was sued that they finally set up a take reduction team. The team was announced in January 2010. These teams have 6 months to produce a draft take reduction plan. Really importantly, although some of us on the team objected, the scope of the team only included longline fisheries, even though there were other fisheries that are generally called nearshore fisheries in Hawaii, although some of them occur 75 or 100 kilometers offshore. There are other fisheries that were definitely overlapping with the pelagic population. The team did include both the main Hawaiian Island and the pelagic populations, though. And for those who aren't familiar with take reduction teams, they're multi-stakeholder teams, so they include fishermen, scientists, conservationists, and managers all on the team, trying to come up with consensus plans to reduce bycatch in that fishery. So the draft take reduction plan that the team produced had a number of measures that went into effect, or that the team thought should go into effect. And one of those was specifically focused on the main Hawaiian Islands population, and that's shown in this map up in the upper right. There was an area of that longline exclusion zone around the main Hawaiian Islands that would shrink towards the main Hawaiian Islands 4 months a year, so longline fishing could occur closer to the islands. And one of the team recommendations was that the outer boundary of that exclusion zone was made year-round to provide some protection to the main Hawaiian Island population. Now, this was 2010. The population wasn't listed as endangered yet, but the biological review team was meeting, and it was pretty clear to the members of the team that this population might end up being listed as endangered. So there was some effort to try to provide some protection to it. The plan that we came up with was to require circle hooks. And if anyone wants to see a circle hook, I've got one here, which should reduce the likelihood of a false killer whale getting hooked in the first place, because circle hooks tend to jaw hook fish, and false killer whales will often leave the head and just take the body of the fish. So it should reduce the hooking rate. The branch lines had a minimum diameter, and the hooks were meant to be weak. So the idea is you'd have a weak hook and a strong branch line, so the hook would be the weakest link. If an animal did get hooked, there was also a recommendation by the team that the hook would have a pull strength not to exceed 325 pounds. So the idea, if it gets hooked, it could potentially straighten that hook and get off, and thus not be left trailing gear. And there were some other recommendations for crew training and crew putting tension on the gear, as well as establishment of a southern exclusion zone, which was meant basically to be a penalty to fishermen if the plan wasn't working, to incentivize them to come back to the table. So the draft take reduction plan, which we produced to 6 months to the day, came out in July 2010. NMFS took a year or so to come out with a draft of their plan for public comment, but then did nothing for over a year. So there was another lawsuit that basically forced them to take action. I was told at the time that one of the reasons why they were delaying was because of the upcoming November 2012 election from the Obama administration, and they basically didn't want to get another hot button protected species issue in the news just prior to the election. So lo and behold, after the election, they come out with a final take reduction plan. Now, most of the things that I showed you in that the draft take reduction plan that the team had come up with ended up being in the final take reduction plan, except for the pull strength criteria for these hooks. And that's really important because it allowed fishermen to stick with 4.5 millimeter maximum hook diameter, but just have them made out of materials that were much stronger. And so some testing that was done on hooks that were being used in the fishery a few years ago showed that instead of the 325-pound pull strength that we had wanted to have, some of them were 600-pound or 700 pounds. So basically the hooks wouldn't straighten. It takes a while, because these events are relatively infrequent, to get information on how well the plan was working. But by 2017, it was really obvious that the plan wasn't working. The interaction rates remain unchanged, which suggests that those circle hooks and jaw hooking the fish were not reducing the likelihood of a false killer whale getting hooked. The false killer whales were still the most frequently entangled or hooked species of cetacean in the fishery. It actually increased after the take reduction plan went into effect, in part, I think, because of misidentification in earlier years. Interaction rates increased from 0.51 per million hooks prior to the plan to 0.84 million hooks after the plan. The mortality rate was actually higher after the plan rather than before. So, every possible metric was showing that things weren't going as expected. Now, one way that the fishermen tried to avoid the consequences of the southern exclusion zone in the take reduction plan is they just shifted some of their fishing effort offshore. So this shows the fishing effort outside the EEZ in red versus inside the EEZ in blue. And as far as they were concerned, if you could get that take inside the EEZ below PBR, then the problem's gone away and nothing was required. That actually led to NMFS trying to come up with ways that would manage the entire population rather than just the population inside the EEZ, which I'll talk about in just a couple minutes. Now, again, NMFS in particular had sustained investment in pelagic false killer whale science, and Cascadia played a big role in that in terms of satellite tagging and photo ID. And a number of publications came out after the plan went into effect that basically tried to better understand the population, better understand the interactions between those pelagic false killer whales and the fisheries, and thus inform further deliberations by the take reduction team. The one thing I mentioned that is a direct response to that increase in fishing effort outside the EEZ is that NMFS has now, and again, this is coming from the science side of NMFS. NMFS has now come up with a way of estimating abundance across the entire range of this particular stock, and it's now this new false killer whale assessment area, and thus able to directly compare bycatch inside and outside the EEZ to the estimated abundance. And from that work, it's showing that overall, based on the US longline fishery, bycatch is greater than PBR by quite a large percentage. There's also been a very recent effort, and I thank Rob Aarons from the Pacific Island Fisheries Science Center for providing these plots. It's currently in review, but there's a very recent effort to use Global Fishing Watch data and the data that are available from the Western and Central Pacific Fishery Commission to try to estimate non-US bycatch within this assessment area. And what they've been able to do is show that the non-US effort is relatively small within that area compared to the US effort. This is the effort in hooks within that assessment area by country. And the very bottom line is what percentage is non-US. And you can see that it ranges from 8.5 to 13 or so percent. And from that, using the interaction rates that are coming from the observer program in the deep set longline fishery, able to come up with an estimate of the number of false killer whales that are taken in these non-US fisheries. And it adds just here it's the mean by years 4.4, with a couple more recent years is now up to 4.8. And so this is sort of what you want, is you want to be able to assess all types of bycatch on a population, not just the US bycatch. The one thing that's missing is, here just 4.4. So in addition to the 47 per year in the US longline fishing. The one thing that's missing is information from other US fisheries that are not subject to any observer programs. So there's a number of what I consider to be fatal flaws in this false killer whale take reduction plan. These non-longline US fisheries were never part of the team mandate. The no pull strength requirement that basically allows a workaround for that weak circle hook. Bycatch of non-US longline fisheries, which were ignored up until now. It hasn't actually gone into the stock assessment report, but I think it's going to be in the next stock assessment report. And then lastly, relying on observers for determining the mortality and serious injury rate when there's very likely an observer effect and only part of the fishery is observed. So for all of those reasons, the take reduction plan is not working. Many of these things have been known for a long time, and since the plan went into effect, there have been no additional regulations that have been put into place. So why not? For the main Hawaiian Island population, NMFS has used for a long time and continues to use, and when I say NMFS, I'm referring to NMFS management, not NMFS scientists. They're using the data uncertainty. So we have all this evidence of fisheries interactions, but all of these nearshore fisheries are managed by the state of Hawaii. None of them are federalized fisheries. There's no observer programs. No one is actually seeing the actual interaction in an animal getting hooked and entangled, dying or otherwise. So NMFS has said, well, we don't know which fishery it is, so we can't do anything about it. And they've been saying that for a long time. I don't know if any of you knew, but we had an administration from 2017 to beginning of 2021 that seemed to be a bit hostile to new regulations. And so I think the local regional office decided to just take a break and not try to put anything forward during that period of time. But what they should have done is get everything set up so that when the administration changed, because after that administration, there was actually a 4-year period where there wasn't a hostile administration, and that would have been a lot of time to take action if there was the institutional will. For both the take reduction plan and for the main Hawaiian Island false killer whale population, really the only solution is some sort of restrictions on fishermen. Those restrictions could be targeted to certain areas or certain gear types, but it's a politically unpopular thing to do and would require a lot of willingness to piss off people, which a lot of people on the management side haven't been willing to do. And then I don't know if anyone noticed, but now that we have a new administration that also appears to be somewhat hostile to new regulations, and so hopes for that window that we had in the previous 4 years closed, and hopes for any changes in the near future, I think, are slim. So I can't end it on quite so depressing a note. So I will say that there's impressive cohort of graduate students that are working on false killer whales and with relevance to false killer whale management issues, and that does give me hope for the future. Not necessarily the near future, but certainly the longer future. If you think about it, prior to this current batch of students, almost all the graduate work that had been done on false killer whales had been done with captive animals, particularly studies of acoustics. And now there's a number of students that are working, including Michaela here, that are producing great science and are also creating a cohort of people that have the knowledge to be able to take some of these things going forward. So with that, I'd be happy to answer any questions.
All right, thank you for a wonderful talk. We will go ahead and start. Are there any questions online to begin with? All right, so that brings us to the room. Questions in the room. All right.
Hi, I was wondering if you could talk about the injuries to the animal, particularly the dorsal fin and the fitness of the animal afterwards.
Yeah, it's a good question. How do these dorsal fin injuries affect fitness? And I should say, the short answer is we don't really know. The dorsal fin is one of the functions of the dorsal fin is for thermal regulation, particularly thermal regulation of the uterus and the testes. And it could potentially influence the likelihood of a female being able to, if that thermal regulatory function is degraded, it could influence the likelihood of a female potentially being able to successfully have a calf born. We have done a drone-based, well, no, we have done a lateral-based assessment of body condition, comparing individuals that had evidence of fisheries interactions to those that don't have evidence of fisheries interactions. But the problem is many of these injuries, the dorsal fin ones are not that cryptic, but they only represent a proportion of those that actually have injuries. And many of the mouthline injuries are difficult to assess or impossible to assess. And so our sample of individuals without injuries, there's actually a bunch of animals in that sample that probably also have had prior fisheries interactions that have involved injuries that we just aren't able to assess. So that's the long answer. Assessing the body condition hasn't been as productive as we hoped. There's also the body condition from the lateral photos. We also found that there's a strong sex difference in body condition that's probably related to gestation and lactation. And yet we don't know the sex of all the individuals in the population, but for those we did, there was this big change in body condition for females. So there's some confounding variables that just made it difficult.
Thank you. Other questions?
Hi, Robin. Great talk. So these are pretty smart animals. Do you think they get hooked more than once, or do they learn and give it up?
Yeah, the 2014 paper, we actually looked at individuals and evidence of acquisition of multiple injuries over time. I didn't mention that the youngest that they start showing up with injuries is about 2 years of age, and that there are a number of individuals that have multiple injuries. I think that it's highly likely that the likelihood of injury, I don't think they stop depredating. But I think that the likelihood of getting injured may decrease after the first injury. I think they probably learn to some degree how to depredate a little bit more safely. The big question is, again, what type of fishing gear they're interacting with. And there's short line gear, which is just like long line gear, but shorter, so it's soaking in the water. And that gear is stable, but then there's other gear like trolling, and we know they do take fish from trollers. It's being reported in the media. And trolling is by far the most common fishing method in Hawaii. And if you're taking a fish that's on a line that's moving fast through the water, I think the likelihood of being able to carefully assess what's the best way to get that fish off the line to minimize an injury to myself, I think it just makes it difficult. If you also notice, the rate of injury seems to be increasing over time. In the 2024 paper, we also looked at the timing of the minimum time when the animal had no injury and when it had an injury. We can't really say when within that window it had the injury, but what the outcome of that is evidence that they're still interacting with gear. This is not all historical interactions that have caused these. And there's some suggestion that there's more interactions happening in recent years. And I think that that's what you would expect, and what has been documented in some other social odontocetes is that these kinds of behaviors spread through the population. And so I don't know whether or not 100% of the false killer whales in this population are regularly depredating, and only 28% have evidence of injuries as a result, or whether it still hasn't spread entirely. But my suspicion is that it's going to continue to spread if it hasn't already saturated the population.
All right. Any questions online yet? Drop your questions in the chat.
Thanks, Robin. Fantastic science, long sustained record. You started your talk by highlighting that the United States at least used to, but still is just barely having the strongest, arguably the strongest legislation in place for protection of marine mammals through the EPA and ESA and MMPA. So I'm going to move to the fact that the injuries are largely or entirely associated with depredation, correct? So presumably the fishers themselves aren't really happy about this. And so my question to you, I realize that this is outside of your area of expertise, but I'm going to ask you to speculate anyway. We end up thinking a lot about how to address these kinds of situations, and you too, I'm sure, globally, where outside of EEZ regions for any particular country, you get into a whole new regulatory area. And in many countries inside their EEZs, there aren't any regulatory authority at all. And so I'm wondering what your thoughts are about, and have you, in this particular case, interacted with the fishers themselves and tried to actually find a solution outside of formal regulatory frameworks? And what are your thoughts about the future possibilities of that here and globally?
Well, certainly with the take reduction team, I mean, there's a whole bunch of fishermen on the team, and over the 15 years the team has existed, there's been some rotation of those fishermen. So I've got to interact with a number of different individuals who have very different perspectives, and some of them younger, some of them older. I do think that during the take reduction plan development, the original take reduction plan development, the team members, including the fishermen, were motivated to try to solve the problem. And the, that one simple thing of not having a pull strength requirement on the hook, even though the team wanted to have that, could have jeopardized the success of that plan. So it's just one simple thing that NIMS decided not to put into effect because it was something that would be very difficult to monitor or test when someone went down to the boat to see. And that's really why they left it out. Give the fishermen some credit. At some of the more recent take reduction team meetings, there was one in 2023 where the fishermen, and part of the reason why the weak hook, strong terminal gear, putting tension on the gear isn't working is because of the risk of throwback of those, flyback of the lead weights that are at the top of the leader. And so fishermen justifiably don't want to put a lot of tension on the gear if there's a risk of injuring themselves or someone standing next to them. And so the fishermen came up with this fighting line device, and then Western Pacific Fishery Council found funding and produced them and provided them to all the boats, which they are using these fighting line devices, although they haven't used them successfully with false killer whales, but the observers are recording when they're used with other species. The fishermen love them for sharks, because what they could do is they basically send this fighting line device down. It basically grapples onto the lead weight and allows them to not be pulling a monofilament line in, but to be putting pressure on this, a polypropylene type line to get the animal in close to the boat. So they're using it with sharks quite regularly so that they can then cut the leader for the sharks. If that would work, I think it would require, I think it might work with false killer whales, but to me, what you need is some sort of way of verifying that it's actually being used when there's no observer on board. And so one of the things that I've been advocating for a long time is electronic monitoring. I mean, fishermen, observers can be paid off. They can be, their sympathies may lie with the fishing community. They may be in their cabins. So I've asked a number of observers what they thought the relationship was between reality and observer data. And most of them thought it was like 90 to 95%, but that 5 to 10% discrepancy could be strategic. And when I say strategic, it could be that when there's a false killer whale caught inside the exclusive economic zone, if that's the one they don't report, then that can have major implications. So I know I'm not getting specifically to your question of what can they do without regulations, but I do feel that there's a role for regulations. I do feel if some of these other changes, like a pull strength requirement that we originally had in the plan, were actually put into effect. When we met in 2017, we talked about stronger branch lines and weaker hooks then, and that was 2017. When we met in 2023, we talked about those things. So we can come up with a lot of ideas that are worth trying, but it still requires the agency to put those into regulation for them to actually happen. Other fishermen that I've talked to from nearshore fisheries, so the ones that are interacting with the main Hawaiian Island population, we published a paper in 2021 that took our satellite tag data and it took what's available for commercial fishing data around the main Hawaiian Islands, and we basically used it to suggest where most of those interactions are occurring and with the main Hawaiian Island population. And for an individual fisherman, paper's called Bringing the Right Fisherman to the Table, for an individual fisherman, where is their individual likelihood of having depredation or hooking occurring, and suggested that it's really in just a few areas along the north shore of Molokai, north tip of Hawaii Island. And so you could put some requirements in place, either electronic monitoring for any boats that want to fish in those areas, or observers for any boats that want to fish in those areas. That I think would very quickly add some information, because what had been happening prior to that, the majority of fishing in Hawaii, close to 70% of all the catch in Hawaii occurs off Kona. And that's because of the huge charter. Well, Kona is a really nice place to go fishing. You know, it's nice calm water. That's where almost all the charter operators are. It's got a reputation for a lot of billfish. And if you ask your average fisherman from Kona if they've ever hooked a false killer whale, they're going to say no, and they're probably telling the truth, because it's not a very important area for false killer whales, and there's a lot of fishermen. So the individual probability of an interaction occurring is very, very low there. But what hasn't happened, and maybe too late to start asking the fishermen that fish in these hot spots, and I say too late because they may not want to provide any answers at this stage. But what hasn't happened is to try to look at those areas where that individual fisherman's likelihood of having an interaction is high. Because I think it could be done, I think something could be done to reduce interactions for the main Hawaiian Island population by focusing on those areas.
All right, I think we have time for one more question. Oh, I see one up there.
Oh, and I have stickers. And for those who were in the Renee's class earlier, I have new stickers, different ones, much nicer ones than the ones that gave out earlier. So.
Thank you for the talk and for the offer of stickers. You said that one of the most likely ways to, achieve this zero mortality or injury rate was to put harsher limits on fisheries. Has there been any sort of estimate about how much this would impact the fishing industry? Would it be a noticeable amount? Would it be more of just a we're making less money or we're going out of business scenario?
Yeah, well, the fishermen replace their gear pretty regularly. All the hooks are probably replaced on a yearly basis or so, because they once they've caught a few big fish, the fishermen just don't want it. They want to remove any variables that could reduce the likelihood of the branch lines get worn and broken, so they replace the branch lines every year. So when the original plan went into effect, there was the fishermen had a lot of warning, and some of them started pre-plan. Just next time they were going to replace their gear anyways, they replaced it with gear that would be compliant. The main economic downside, I think, to hooks that are weaker, truly weaker, rather than just a minimum wire diameter, is the fishermen potentially losing big fish. And there is a definite economic cost of that. And I think a lot of it depends on what the profit margins are. If you ask any of the fishermen on the team, they'll say it's a large economic cost. But I don't know. They get hooks back that are straightened, and they don't know what was on the hook that straightened it. So I think there is a certain amount of uncertainty in those estimates.
All right, well, thank you so much. Let's go ahead and give him one more round of applause, and thank you. All right, and it sounds like we will be continuing this discussion at Rogue Sunset Bar across the street, safely across the street if you're going over there. So you can continue asking questions and thank him for the stickers. Otherwise, we hope to see you next week with Dr. White Bear. And yeah, happy Thursday, everyone. We'll see you next time.